So this is Robbie, I'm Attila, and this talk will be about security automation, especially security monitoring automation. How many of you have seen so far that your Itzinga or something other monitoring system was connected to a telephone system? So if something goes wrong, you get an automated phone call. Yeah, I think this is pretty common. How many of you have the same for your critical IDS alerts? Do you trust your IDS alerts? It's quite uncommon. And it has a pretty good reason. If something fails at an infrastructure level, for example, you start experiencing packet loss, or your database server starts wrapping, you can get clear metrics out of it. You see your users slow down, or in severe cases, at Prezi, they can't present anymore. That's when we can see an outage, and we can get clear statistics, what an outage is and when it happens. Security is very different. You see an attacker's moves by event, and that's the only thing you can see. Because an attacker usually don't break your system. He wants to hide. And he has pretty good chances to hide because usually your daily operation produces the very same traces as an attacker would. The reason I'm talking about this here, that we started the bug bounty program exactly a year ago. We announced it at Hacktivity. And that time we started monitoring almost everything, and we had a goal as a team to catch a possible vulnerability before it is reported. And we are still running this bug bounty program, even here. So after the presentation, we have a bug bounty corner in the leisure zone. The same bug bounty rules applied, so if you find something, we will cash it out, so we will pay for the responsibly disclosed bugs, but this time we are there to help you. So if we think that you are on a good way to find actually something, we can look up the source code for you and do everything necessary to find the bug. And we would like to have phone calls. We would like to improve our monitoring system. That's our benefit from our presence here. And if you want to have a phone calls, we need very clear signals. If you just check the output of your intrusion detection system, that's usually very noisy. For example, it has all the automated scanners the bug bounty researchers do. But those are informal. In case of emergency, that's a pretty good audit trail to look at. But you want something stronger. You want something that you can have a phone call that wakes you up at 3 in the morning. So we defined what kind of signals do we want to connect to our telephones. We say that on average, every second phone call we get should be because of a malicious activity. So that's our recall ratio. And this is two types of things. So first, you have to have really good monitoring to have all the events necessary. Second, you have to be excellent at filtering out what's the noise. And this is something I have to tell before I go deeper what we did, our development process and how we think about security. Currently, we are a team of 3 in the security engineering team, and we have a lot more developers. What we'd like to achieve is scaling security, where scaling means they create exponential complexity. We double the developer size every year. We want to keep up with this pace. And there's one very important aspect. We don't want to block them. we call it we are running in a non-blocking mode, which means we trust them that what they do is good, but we want to catch if it's not true. We don't want to have policies how they should develop, what frameworks should they use, and we don't want to have mandatory code reviews before releases, because that's not how they work. Two buzzwords, agile, DevOps, that's what we do. Every team is responsible for a specific part of the product, from planning to the deployment and running it in production. So we hooked their process to get some kind of alerts. First, we hooked the development process. We have an open source tool called RepoGuard. RepoGuard will check the Git commits on GitHub and try to find specific patterns of bad practices. We use several technologies, some exotic languages like Haskell, and RepoGuard is basically just a set of rules we run against their commits. For example, if I see that in an HTML, JavaScript, or something like that file, someone typed .inner.html. 1 out of 3 cases, I'll find something suspicious that the developer is just about to introduce a new cross-site scripting vulnerability into the site. And when we find it, then we notify them. We hooked the deployment process. We run on Amazon Web Services, which is the cloud platform of Amazon. Developers can fire up new instances, new load balancers, new everything at their will. And the AWS has a pretty good API to check the actual status. And we use a tool to track the changes in this status and find similar patterns we used in Red Alert, in RepoGuard, but for now for infrastructure. For example, someone changed something in the firewall policy, which is called security group in Amazon's terminology. And we also do vulnerability scans, automated. This is that every bug bounty researcher on the internet do. So we are pretty confident that we won't break anything when we run our tests. And it's better to find these issues ourselves and not wait until someone reports. We catch the traffic logs from the site, so every HTTP request you receive, and we catch the interesting application events. Someone started presenting, someone logged in, someone failed to log in, someone shared a present, things like that. And we have AuditD and Suricata as well on lower levels. AuditD is an audit tool or framework for Linux. You can subscribe to specific events. For example, someone opened a file, someone called exec/syscall, and basically everything. And Suricata is an intrusion detection system which will search for patterns in your traffic log. And these systems altogether produce us at peak hours 2,500 events every second. And the events themselves, in most of the cases, don't make too much sense in themselves. Because what we are looking for are called complex events. Not one event, but several events will create a pattern that we'd like to match to. And I'd like to give you an example again with the firewall thing. So a developer opens up a new port or port range on a firewall setting. That's something we will look at, but who cares? I mean, it's not urgent, we trust them, and it's likely that they won't introduce new bugs. What if we knew from previous events that a machine is running with that security group? It elevates the urgency. So probably the who cares mentality doesn't apply anymore. We have to take a look now. And what if an unknown service binds to that port which is visible to the public on one of those machines that are in this security group? This is something we definitely want to look at as fast as possible. And for a long time, we did these kind of analytics on a Hadoop cluster with big technology, and it was pretty good to find the uncommonly common things. For example, there are several flash files at our site, but most of them are called with known get parameters. If we see that something new get parameter or something new value is used, then we'd like to check it because it's probably a reflected XSS. The problem with Hadoop was its speed. To run all our jobs took half an hour, and we had to run it periodically. That was the time when we started using Elasticsearch to solve this problem. Elasticsearch is a document-based database engine, distributed, and has an excellent stack to ship all our logs to the database and to retrieve it. The part of the stack is the tool called Logstash. Logstash can read up your log file, give some meaning to it. So from the unstructured log messages, it can create structured log messages by parsing it, and then feed it to the Elasticsearch database, where you can search it. And we use a web front end called Kibana, which gives us all the analytic capabilities that Elasticsearch has. So right now, we are able to do some basic thing with events, so basic correlations. And the fun thing is that we recognize that the way we store the logs strongly correlates how we use it. Now that we can query it up very fast, we started building automations on top of it. There are typical things you do when you receive an alert that possibly CSRF attack is going on. You'll check, for example, the distribution of the location headers you receive, the referrer header you receive. You see how many people actually got to your site without CSRF token. So you collect these infos automatically because in case of emergency, you don't want to wait for your systems. You want all your data ready, and you want to be the slowest component in the system. When we started doing these automations, we did several things. For example, a developer starts a new EC2 instance with a base image that we haven't seen before. That's probably a sign that we should do an automated vulnerability scan against that host or against that AMI. This is the terminology for Amazon for a base image. For events that are likely to be false positive, but we'd like to make sure to receive these events, we do chat alerts to a chat room. For example, the user statistics of a specific endpoint changed. This can be a sign of an ongoing brute force attempt. So we receive a chat alert of it. When we have an event that we can strongly relate to a developer, for example, a Git commit, then probably we can send automated emails to him to resolve it himself, so we don't have to work that much. And for the most severe and most quality signals, we do PagerDuty, which is a service to call us at our telephone. There are several ways to build such a system. My team has a culture to choose always a straightforward way. We had the database, the Elasticsearch database, with all the historical data, and with very strong instances serving it. So we can create analytical queries against it. And we query periodically anyway. And we had an idea. What if we could create a simple rule engine to query it periodically and check the same things that I mentioned before? And this is where we can do the complex event processing part of the system, because we introduced a new database where we store the temporal data, the learnings we already learned from the scene events, and we can take actions based on that. Typically, a learning has a limited lifetime, from seconds to weeks to months. And what is simple rule engine? This is really simple. We wanted to have two things: easy create rules in Python, and a framework that supports looking up extra information. I'll tell you it through an example. When an attacker successfully exploits, for example, a directory traversal, typical thing, he tries is accessing etc password, which is allowed, typically, and then he tries to check if etc shadow is accessible, if the process is running as a root. So what if we use ODD to check the failed attempts to etc shadow? Unfortunately, many programs access etc shadow all the time without permission, and you don't want to investigate all the time. Probably you want to investigate it at the first occurrence, but definitely not anymore. So that's why we have to match the previous events to, which is very similar to this one, what I received, and suppress it if it's a clear duplicate. Sometimes I like to do simple queries against the knowledge I already built up. If a process which tries to access etc shadow has the same process group and process session as the supervisor daemon, then it's pretty severe, so I'd like to check it, because it indicates that it's probably a long-running service. And sometimes you want to do you want to discover complex relationships. For example, you want to know how long this process is running that you receive the alert right now. So for example, you want to do complex queries against the historical database. That's the third type of thing that our system supports. And now when you have all the necessary information, you can decide what to do. Either you can take actions, or you can say, okay, let's wait for other events, and just store all the knowledge I have right now into the learnings database. And the system I showed you is pretty easy. It was pretty straightforward, and probably not the best way to solve the complex event processing framework. And I think the main takeaway here is that you have many tools, you have many events that you receive. You have to have some sort of system that will collect the important information out of it. Typically, when you receive all these events from the IDS, firewall, etc., you see a lot of noise. There are two things you can do here. One, suppress the known patterns that you can link to a specific normal operation, and what is left there, you might say that's interesting, which is true, but that's still noisy. The other type of thinking is saying, what if I would be an attacker? What's my attack path? And try to capture things there. And if you put the two things together, you'll see pretty strong alerts. And it's very important to keep an open eye on new detection techniques, because they can introduce you quite new and good shortcuts to solve complex event processing problems. And now I'd like to hand over to Robbie, who will show you these kind of tricks in practice.
Thanks, and welcome, everyone. So, you have heard from Attila. He described it pretty nicely how we got here and how the problems we have faced and the solutions we have come up and the theory about it, basically. So it was theoretical, like complex events and stuff like this. Now you might ask, why would you believe that it works in practice? This is why I'm here now, and I would like to show you 5 examples and a live demo about what we do in practice, and probably prove it to you that these kind of concepts and ideas can make your life easier and that they can really work. So let me start with a statement like, this is not rocket science for what we are talking about. So these kind of things which we are presenting right now, you don't need a PhD to do that kind of things. It's more about the ideas and the mindset, like continuously improving stuffs, learning from your mistakes, and think as an attacker would do. So I would like to show you these 5 examples for these kind of things. For example, what Attila already mentioned, suppress common or known patterns, and then show one example which shows that you should alert on clear signals, then that you should trigger automated actions if you can do that, then that you not only have to collect the logs, but also correlate and use simple detection mechanisms to find attacks, and then that you should continuously improve your monitoring. So let me start with the first one. In order to suppress the common patterns, you need to know your system. And I would like to give this example to you that we come up with the idea, let's detect strange requests. Okay, but what is a strange request? We defined it in several ways. Some of them was like, okay, we see in the access log that someone requested a URL with some redirection parameter set to a non-prezi.com domain, which would mean that he has found an endpoint which redirects the user, and now he tries to exploit it to make an open redirect attack against us and maybe use it for phishing or stuff like this. So the first one is like to see if it's an open redirect vulnerability getting exploited. And the second one, to see external post requests to our site, because we didn't put any forms out in the world. So as a valid request, there shouldn't be any post requests to our site. Get requests, they are fine, but no post requests. Unfortunately, some of our old embedded Prezi code, they do some post requests to our system, so we had to suppress them, but what is left is usually interesting. So why would we detect external post requests? Because if we see a lot of them, it might mean that a CSRF attack is exploited. Okay, so let me give you an example that happened to us. We have received a simple alert, oh, there is an external post request to this URL. Well, looking at the URL, we were like, that red thing there, this is one of our media storage's path. And the other stuff, the converted PNG, that looks like a converted media path. So why is it included in the URL itself? And then it turned out that the external post request itself, it was a false positive. So it was totally valid. We had some really strange old code which uses and sends a post request to our site, and it's fine. But we were like, okay, let's investigate it further, what this endpoint really does. And as it turned out, it's pretty bad because it gives you back a read-write token for our media storage, which means like by using this endpoint, you could replace the red stuff and stuff after it to anything you want. And basically, you are able to read and write all the kind of the files which we store in the cloud. So that's really, really bad. And so it was a critical bug. We fixed it immediately, but we wouldn't have been able to detect these kind of things without checking strange requests, or at least in that case, it helped us. So it's really worth to check those strange requests. So what I suggest you is to monitor everything and try to know your system better. And when you know it better, you know what to suppress, and what is left is usually interesting. So it's kind of like finding a needle in the haystack. And if you know those parts of the haystack where the needle can't be, you just take it, put it away, and what is left is a smaller haystack, and you will more probably to find the needle in it. So it's easier. And what if this needle is not small, but a really huge stick, which you don't even have to find or search for? What I mean is, like, what if you have a really clear signal? Like Attila mentioned some of those. For example, someone accidentally committed a secret to one of your public repositories. This means that since it's a public repository, anyone can find it, they can use it. If it's a production secret, they can misuse it, and it's really bad. And it happened to us once that it happened, and we want to detect these kind of things. But wait, we have RepoGuard. It was created for this kind of stuff. So RepoGuard found this commit when someone committed the secret, and it sent us an email alert. Well, we were quite busy with our projects, and we didn't check our inbox, and it turned out that we only received this email after a day. So the production secret was in a public repository, which probably nobody knew, only 1-2%, but still, it's bad, and we only noticed it after 1 day. So it's definitely something which we want to change. And we have this culture in our company that we try to learn from our mistakes, and so we organize so-called post-mortem meetings, which is every time we face some critical bug or we somehow fail as a security team, we organize a post-mortem meeting afterwards where we review the whole timeline, like what happened and when, spot where we could improve in these actions, and also come up with 2 types of tasks. One, to detect these kind of bugs or situations happening in the future, and also to prevent it, and that's more important. So we come up with 2 post-mortem ideas. First, let's make a clear alert on committing a secret into a public repository, and because we were thinking about it, we come up with another like attack path, like what happens if a private repository is made public and there was a secret already committed into it, like previously. So it's not like it's already public and someone commits a secret, but it was like the secret was committed previously and then the private repository was made public. So we improved RepoGuard, and now we include this type of information in the alert as well. And the other thing where we have failed is the time. So we created a PagerDuty alert for these type of things. So right now, if somebody commits a secret into one of our public repositories, like in 5 or 10 minutes, we got a phone call from PagerDuty about it. So even if we are busy with our projects, we get notified about it. So what's the learning from here is that I strongly encourage everyone to try to because it's a really good practice to learn from your mistakes, so try to do post-mortem meetings, and if you have clear signals, then you should have an alert for it. Okay, now I have been talking about how to improve your alerts. Now I would like to give an example how you can make your life easier and automate stuff which you would have to do otherwise. So this is something which Attila has already talked about, like we do automatic vulnerability scans, and in this case we chose a Nessus, for example. And why is it good for us? Because it can detect like famous bugs and outdated packages and all these low-hanging fruits which you can test from outside as a black box test, and what all the pen testers, bug bounty researchers, or black hat hackers would do first. So why not do this before them and fix those low-hanging fruits before they found it? So we don't want to scan all the hundreds of instances we have, because usually they are okay, and once we have finished them, scanned them, they are pretty in the same state. So we only want to bother with newly fired instances and those which have been modified. For example, someone installed a new package on it. But for these kind of events, we already have a tool. It is called Red Alert. It can send us an alert when a new or modified instance comes up, and then, based on this alert, we can do some automated triggers with this security control center engine, which we have created, and we trigger an automatic Nessus scan, and when the scan is over, it fetches the results, and based on the result, it decides if there is any severe bug, which it should send an alert to us. So, yeah, as I've mentioned, we use it right now as a bug bounty researcher would do, so we only do black box scans yet, but we are planning to do white box scans as well. So like when Nessus can SSH into the box and do local checks too, because that would be some added value compared to any other attacker that we have the SSH keys to our servers. And we hope that we are the only one who has them. So why is it good? Because it helps to raise the bar for valid submissions, and it also helps to raise. It also helps to attract better attackers. So, like if you fix all the low-hanging fruits, then all the bug bounty submissions you will get, it has to be like better quality, because they had to do more stuff, not just the basic stuff. Okay, Okay, the moral here is like trigger automated actions if you can, and raise the bar because then you can attract better or smarter attackers. And now, before my last example, yeah, I would like to talk about what if you have raised the bar. So it means like your system is safer in terms of technical stuff at least, but what about the human factor? So like, we definitely want to detect if one of our staff accounts is brute forced. But since we got brute force attempts all the day, so until they are not successful, we don't really care about them. We only want to detect successful brute force attempts. And for that, of course, we could use stuff like rate limiting and use a stronger password policy, but we think that it still won't be enough. Like even if we implement these kind of protections, there is some probability that one of our staff accounts will be hacked or brute forced because there will be an attacker with bigger resources, more time, and if he's destined enough, then he can manage it. So we definitely want to detect these kind of things. So for that, we aggregate all the application logs we have and try to detect for patterns. For example, these are quite simple patterns, but they work. So for example, after a lot of failed login attempts, we see one successful login attempt. That can be either that. So what happens if we see something like this? We send an email to the affected staff user and also one for us. And why to send it to the staff user himself? Because just think about it. If you get an email like this, what would be your first action? You will call the staff user like, hey, was it you who tried to log in 40 times and failed? And then you suddenly remembered your password and it was successful? And if he says yes, well, okay, that's fine. I mean, that can happen. But if he says no, well, then that's something where you have to do some actions immediately. And so what if he sees this email before you? And he can, like in a self-service manner, can disable his account because he sees like, hey, it wasn't me who tried to like brute force my account and was successful. So just let's disable it because that's what the email says. And then even if I'm sleeping or even if I'm somehow not reachable, he can do this for himself. So it's pretty easy to find these kind of things in logs. You just have to use some simple pattern matching, and it's I think it's really good practice to automatically notify the affected users themselves. Because as Attila said, you would like to be the slowest component in the whole incident response thing. So those things which you can automate and do like automatically upon an alert, you should do it. And now, I would like to invite you to my live demo and involve you in it. And I have a question which might look pretty unrelated. How would you ring me if you don't know my phone number? And like finding me on the internet doesn't count now. So we have created a test site. It's available at ringme.presiteams.com/8000. And I encourage you, I don't know who has laptops right now, but if you could access this site and find the vulnerability which we have put there, it's a pretty simple one, then we will see what happens. So again, it's like ringme.presiteams.com/8000. And I see no laptops opening, whatever, we will see. So my last example. It's a story of a cross-site scripting vulnerability. It's cross-site scripting. It's an old story. It's all over the internet. Since we have launched our bug bounty program, we have got a lot of submissions relating to cross-site scripting as well. So let me tell you a story about a young researcher who wants to get some cash. And he thinks like, OK, I want to have some cash. I have heard that Prezi has launched its bug bounty program, so let's find some cross-site scripting vulnerability in it. What does he do? He fires up his favorite search engine, types Prezi XSS, and Prezi is like, oh, I'm feeling lucky. Let's see the first result. And as it turned out, the first result was Prezi, which a previous bug bounty researcher has created, and he put like XSS payload everywhere, in the Prezi title, the Prezi description, the Prezi itself, the comments, and everywhere. And so when this young researcher has opened this Prezi, guess what happened? Ta-da! Working cross-site scripting. So he was like, oh, I'm really feeling lucky now. So let's create my own proof of concept Prezi, just copy the title from the previous Prezi and send this as my own submission. And and since it was a valid submission, it was really a cross-site scripting, we have rewarded him with $500, and maybe he thought that, okay, now let's find another XSS somewhere else. So what's the conclusion about this story? Or why is it interesting? First, because as it turned out, he found this bug in an experimental feature which was released 3 hours ago. So like, they are really continuously testing our site, and even like only after 3 hours it has been pushed to production, they have found it. Of course, it was easy, but still, that's 3 hours. So. And of course, we had a post-mortem meeting after that. And one of the tasks we decided is to insert our XSS hook into every page. What is this XSS hook? Well, it's a pretty good idea, and it's pretty simple. You hook every alert, prompt, and confirm JavaScript calls on your website and send a log alert or when it triggers. And why is it good? Because if an attacker is able to do a cross-site scripting on your site, the first thing he will try is like alert 1 or alert XSS or something like this, or prompt or these kind of things. So if he does it and it really works, then it will pop up a window in his browser and also send us an alert that, hey, it's probably a valid XSS on our site. And so we had this detection mechanism, but it didn't trigger in that case. So we have investigated what happened, and it turned out that we had a hidden iframe where we forgot to put this hook code. So the moral here is, I think, that bug bounty is worth it, and the researchers continuously test your site. So why is it good? Because it helps you to highlight the weaknesses in your monitoring. And if you think about it, it's like they are monitoring your security monitoring, which is pretty good. I mean, like, do you monitor your security monitoring somehow? I mean, that's really cool stuff. And now, I don't know who has found the the vulnerability in the test site. It was pretty easy. If you just opened up this URL I gave you, it would redirect you to prezi.com. But with this redirection, it was, oh, we have a phone call. OK, let's hear it.
Triggered incident on security. The failure is Suricata alert. Open redirect bomb exploited from IP 10.137.84.133 XFF. None.
Whatever. So open redirect. Wow. OK, so somebody found it, and we got a PagerDuty alert about it. Let's see what I would do if I get this call, like in a real-life scenario. We have, I mean, Attila have talked about our monitoring system, so I would fire it up, load it in the browser. I hope you can see it. I will zoom into it. So let's see our Suricata alerts. That is, by the way, Kibana's interface. So it fetches our Elasticsearch database. And I just refresh to see the newly coming things. And yeah, I think that's it. Open redirect one exploited. OK. And what I want to show you is this, and I will zoom into it because, of course, you cannot see anything. So among other things like the source IP, destination IP, whatever, you can, for example, see the whole HTTP packet, which in this case is a HTTP response. So you can see that the location was http and evil.com. And of course, you have other informations as well. So that's why it is good to have a good monitoring system. And when you have good monitoring system and quality signals, you can have stuff like PagerDuty like this. OK, so that was my live demo. And thanks for anyone who sent it. So how it works. We wanted to detect open redirect vulnerability because it's pretty severe, and we wanted to detect them. And first, we had the Hadoop-based solution, and we were looking for, in the requests themselves, to see if they are trying to put some non-prezi.com into the URL. But they had a really high false positive ratio. So then we changed our mindset, and we said, OK, what if we look for the responses? And look for location. Actually, the location header is pointing to something which is not prezi.com. That means that whatever the request was, the response is an open redirect response. So now, and yeah, of course, we have to whitelist Facebook and LinkedIn and those sites which we are redirecting to because of OAuth. So it's pretty simple. With Suricata, you can do it in like 10 minutes, and it has quite 0% false positive ratio. So it made our detection mechanisms quite obsolete. And since it's a quality signal, we can have a PagerDuty alert for it. So learnings from this is that with help of simple ideas, like look for the response, and existing tools, Suricata, one critical vulnerability can be detected with almost 100% confidence, which is pretty good. I mean, like, if you have these kind of clear signals, why don't you have an alert for them? And as a final thought, I would like to just highlight again what I have and what we were talking about. So probably the green graph is like Suricata alerts or something which is like somehow security related. And if you suppress the common and the known patterns, then you might get the blue line, which is like worth checking manually, but still a lot. And there is this few requests, the orange one, which is a clear signal, really clear one. So why don't you have an alert for that? And I hope that after this presentation, you will think about what kind of clear alerts you could have, and how could you trigger automated actions, and how could you know your system better so you can suppress the known patterns. Thanks for your attention.